Hello everyone, this is Ms. Samra. I'm back with my next lesson. So we still have 7-2. We are still learning by matrices. I'm just continuing that section. So again, we have done addition, subtraction, multiplication, and we are actually moving forward towards division. So we have done determinant already, and as I told you guys before, determinant is a step towards division. So let's talk about few more concepts that would lead you towards division. Okay, so let's try understanding another concept about division. When I say divide, so basically what we do is, let's say we have some number a. If I say divide by 8, let's just say 8, you could write it like this, or you could even say a times 1/8, which is the same thing, or it could also be written as, if you look at closely, basically it's the same thing but written 3 different ways. Here's I literally divided by that number. Here's I multiply by the reciprocal. Here's I just put the number with negative exponent. I hope you remember, if it's negative exponent, basically it's just the same thing, like you just have to take it to the opposite side. But okay, now here, this is what happens with matrices. We don't divide by any matrix, so this cannot be one of the way we would be using. We don't multiply by the reciprocal either. So the only way we're going to be following for division, it's going to be this. So basically, you just have to put over one, which is called inverse of that matrix. So we're going to be following inverse. So how do we do that? That's what I'm going to show you today. So just like determinant, we have 2x2 does a different process and 3x3 is a different process. So today's lesson is mainly focused on 2x2 matrices. How to find inverse of 2x2 matrices. So how to find inverse of 2x2 matrices. Okay. That was one of the things. One more thing you need to understand, and again, if you want to follow along, you can just look at the notes. I'm on second page of that packet I sent you. So when I say division, there's another thing you need to understand. So just think about this. If this is my original number, and if I multiply by its reciprocal or the inverse, isn't it that's how it's going to look like? This or is the same thing, right? What happens if you multiply a number by its reciprocal or its inverse? 8 times 1/8. What would be my answer? So my answer would be 1. There you go. So basically what's going to happen is, if you multiply your original matrix by its inverse matrix, so your answer is going to be 1. But I hope you remember from the first lesson when we started learning about matrices, I said there's no way you can write 1 in matrix. There has to be identity matrix, which would look, so your matrix, which is same as 1, it would look something like this. If it's 2x2 matrix, then your answer would be this. If it's 3x3 matrix, then your answer would look something like, here you go. So that's the idea. So let's say we are done with inverse. So let's say at the end, if I multiply my inverse matrix by my original matrix, so my answer always should have something like this. You could do that just to verify that. You could always do that. Yeah. So let me show you a few concepts here. So let's start off with actual inverse process here. How do we find inverse? Okay. For finding inverse, which is, this is the symbol for inverse. So what we do is, don't forget, we're doing 2x2s today. So today we're just finding inverse of 2x2s. So inverse of 2x2. So first thing you gotta do is, it's 1 over determinant, and then we multiply this by adjoint matrix. Oops, my bad. So times it by adjoint matrix. So you'll see this equation on third page of your note. Okay, so I guess you already know what determinant means, right? We already know how to figure that out. How do we find adjoint matrix? So let me show you that. So let's just talk about that first. How do we find adjoint matrix? Basically, this is the first equation on the top of third page, where you see 1 over AD minus BC, and whatever the matrix you see next to that, it's nothing else. That's called adjoint. All right. Gosh, why I'm putting like that? Okay. So it's nothing else, it's just adjoint matrix. Okay, how do we find adjoint? Let's talk about that. Adjoint, you have to do 2 different steps. So let's say if this is my original matrix, A, B, C, and D. So in order to find adjoint of this, again I do that. Okay, adjoint, you have to do 2 different steps. For A and D, we swap those 2. So now for the adjoint matrix, D would go here and A would go here. For the other diagonal, which is this one here, we just switch signs. So we switch signs. So this would becomes negative B and this is negative C. Here you go. So that's how we figure out adjoint. So once you have this adjoint matrix, just times it by 1 over determinant. That's how we find inverse of 2 by 2. So now let me show you an example. Again, if you don't understand any of these steps, so please pause the video and you can go back and then replay that part. So let's look at my first example. So I have 4, 7, 2, 6. This is my original matrix and I'm trying to find inverse of this. And first thing you have to have is, let me just write that down. So in order to find inverse, you have to have 1 over determinant and then adjoint matrix. So let's just figure out determinant first. I hope you remember 2 by 2, we just take the diagonals. So I'm just gonna label this as, and okay, determinant of this matrix A is, so 4 times 6, 24, minus 2, 7, 14, so determinant is 10. Alright, so I'm done with this part here. Let's figure out adjoint. So let's just say adjoint matrix would be, okay, you need to swap these 2. This becomes 6 and 4 and switch signs for the other diagonal. So it's negative 7 and negative 2. Now once you have these 2 things, pretty much now all you have to do is just putting these 2 together. So A inverse is 1 over determinant, which is 10, and adjoint is 6 minus negative 7, negative 2, and 4, and at the end pretty much you just have to multiply these together. Now keep in mind, it's a number getting multiplied by a matrix. It's not matrix multiplication, it's scalar multiplication. If you multiply a matrix by a number, it's literally multiplying every single number by the constant outside. So 6 times 1/10 would become 6/10. 7 times 1/10, negative 7/10, negative 2/10, and 4/10. And that's my inverse. Here you go. Now, this is all I have, but like I still want you to understand if this process actually works or not. I really want you to see that. So let me show you how to verify if this is my inverse or not. And remember, in order to verify, what you could do is, if you multiply your original by its inverse, your answer has to be identity matrix. Let's check if that happens with this or not. So my original matrix was, it was, hold on, where is that? It's, where did I put my original one? Oh yeah, it's here. 4, 7, 2, 6. So original is 4, 7, 2, 6. If I multiply this by its inverse matrix, which is 6/10, negative 7/10, negative 2/10, 4/10. Let's check if this is actually inverse or not. Okay, now since this is 2 by 2, this is 2 by 2, inside numbers work. Yep, so it means I can find the product. Outside would be your answer. So my answer matrix would be 2 by 2. Hey guys, to keep in mind, I'm showing you this process just to give you better understanding, like this process actually works. You don't have to do it, but just to give you better understanding, that's why I'm doing this. Okay, all right, so 2 by 2 means you would have 2 numbers, 2 rows, 2 columns. So first I would take this row, I would multiply by this column. 4 times 6, so that would be 24/10. 7 times negative 2/10, that would be negative 14/10. If I simplify, that would be 10/10, which is 10 over 10, which is 1. Here you go. All right. Now let's move on to this one here. I have 1 and 2. So first row, second column. 4 times negative 7/10 would be negative 28/10. 7 times positive 4/10 is positive 28/10, which would be 0 if you add. Okay, let me erase this whole. Okay, now back to this. Now if I have 2 1s, so it means I would take second row times it by first column. 2 times 6/10 would be, let me erase this. 2 times 6/10 would be 12/10, and 6 times negative 2/10 is negative 12/10, which eventually going to be 0. All right, now 2 6 times it by second column here. So 2 times 7/10, it's negative 14/10. 6 times 4/10, it's positive 24/10, which simplified to 10/10, which is simplify 1. Here you go. So if I simplify the entire thing, my answer is this. So it means this matrix is actually the inverse of this original matrix. Again, you don't have to check all the time. I showed you just to show you that like this process actually works. So yeah, this is pretty much all. So thank you for watching. Stay